Hi, good evening. Thanks for joining this webinar. So today we're going to introduce a large language model. It will be high-level overview of LLM and how it works, and I'll introduce some relevant resources as well. So without further ado, let's get started. Just a quick introduction to the generative AI landscape. There are a lot of terminologies: AI, machine learning, deep learning, Gen AI, LLM. I think this graph sort of summarized the relationship among different terminologies. AI is this very broad, right? And it's usually tied to specific applications such as robotics. And machine learning is part of AI. And when people talk about machine learning nowadays, I think they're mainly referring to the classical machine learning algorithms, such as classification problems, regression problems, unsupervised learning, supervised learning. And of course, in deep learning, when we deal with computer vision, a lot of these problems are also machine learning problems, supervised or unsupervised. Deep learning is part of machine learning, and with a specific focus on neural network or deep neural networks. When we talk about deep learning, we start to talk about specialization or specific use cases such as computer vision, natural language processing, and generative AI is just a part of it. And LLM, which is specific to language models, is just part of the generative AI family. If you look at the traditional machine learning, it expects some sort of input, right? Whether it's image input or structured data or text input, and it generates the output. The output could be predicting some numeric value, right? Such as time series forecasting, predicting house price. It could be binary, prediction, which is classification problem. In this example, we feed into the machine learning algorithm, some images, blueberry muffin, Chihuahua pictures. They kind of look similar on these pictures, but the model or the ML model will be able to figure out, which one is blueberry muffin and which one is Chihuahua pictures, with relative, high accuracy. The traditional ML or deep learning models require a lot of labeled data for training when it comes to supervised learning. And that pose some big challenges because labeled data is often hard to acquire in real life. So you need people to help you do annotation. And that's why a lot of the research are based on curated data or the open source annotated data. And ImageNet is one of those examples, but 3 years of effort has gone into building the ImageNet dataset. And before we had some breakthrough using deep neural network in the computer vision space. How do we label data? We can leverage Mechanical Turks, right? Or Amazon has the SageMaker data annotation service, but there are a lot of third-party platforms that help you label data, but it's not free. It comes with it's usually quite expensive. There are open source data annotation tools out there, but if you do that yourself, then you can only do that at a smaller scale. Imagine you have millions of images, and I think the data is actually a bigger problem or challenge you're going to face in real life, and you need to make sure that you have very high quality labeled data before you can train a very solid model. So how can we possibly label so much data? It's very hard. So can we do something else? Try something else. And self-supervised learning is just one of those approaches that allows us to sort of avoid, annotating a lot of the data, and it construct the sort of label the data automatically. And large language model is just one example of that, and specifically talking about the models that does the next token, right, prediction. And most of the LLMs that are very popular nowadays, when we pre-train them, they're usually done in a self-supervised learning approach. But essentially, if we have a sentence, right, nothing is impossible, and we can actually just construct a training data Nothing, right, is predicting the next word is, and nothing is predicting the next word impossible. So the word, before the word you would like to, in this case, impossible, right? Nothing is then becomes the context or the training data we use to predict the impossible. And that's an example of self-supervised learning. And that happens to, allow us to solve the scalability challenge when it comes to data annotation. And most of the Gen AI or large language model, LLM applications are actually powered by this approach. Again, Gen AI or large language modeling, which is a specific use case of that, they take input and output as well. But the input, instead of an image or structured data, it could be text prompt, right? It's expecting a text prompt, and then it generates the output. Output could be answers, so you can do text to text, right? But you can do text to image as well, or even image to text if you use image as an input, and you can expect the LLM or the vision models to sort of summarize what's in that picture. So what is large language model or LLM? And the most popular LLMs out there today, they are autoregressive models, but those are basically just next token predictor. You've seen this example previously. In this example, for example, the Toronto Raptors won the 2019. If you would like to complete this sentence and predict the next word, you feed that into a large language model, and it will basically predict the next token, right? The next token could be NBA, or Toronto Raptors won the 2019 basketball or football. And then these tokens, get rank ordered, and we can pick the highest probability. This is just one approach used to do a completion. Right. OpenAI might try a slightly different approach to do this kind of prediction, but all of these are next token prediction models, basically. But we need a lot of data, right, to train a large language model, and that's why not just data, but also computation power. But how much data are we talking about? For example, Meta open sourced the Llama 2 model. I believe they're working on the Llama 3. Another open source model is the TII Falcon 180B, or they have 40B and 7 billion model as well. These models are pre-trained on trillions of tokens, and very expensive to train, right? So they need to feed a lot of text data into the algorithm. And if you look at the data sets used for training the Meta Llama model, it leverages data inputs such as Common Crawl, which is like a snapshot of the web. It basically crawl the entire web, and that is a massive data set. Seems to be 67% of the entire training data. They use Google C4, some GitHub data, Wikipedia, book data, research articles, but this is not the entire web, right? Because if you look at the data size, it's roughly 5 or 5 billion or 5-6 terabyte of data, but internet, right, generates millions of terabytes of data on a daily basis. So I think based on our available computing power today, if you would like to pre-train the models, large language models on the all the data we collect on a single day, I don't think we have enough computing power, or it's going to be too expensive to do. But when we prepare these data, right, it probably begin with much bigger data set, because you need to do a lot of data cleaning, a lot of data deduplication as well, because there are a lot of duplicated content on the web. So to be able to pre-train a really decent large language model, most of the efforts are actually spent on cleaning the data, right? Get the data ready. And that does require a lot of computing power, and of course it's based on the idea which comes from Google's a paper called "Attention is all you need," and this is the the algorithm that allows us to actually scale large language model training. It's very expensive, requires a lot of GPU cards, right? And I think the Falcon models was trained on two 300 A100 GPUs, but the Meta Llama model was trained on way more, I think, GPU cards. So you need efficient algorithms to make this possible, and the attention mechanism allows us to achieve that scale. How much does it cost? I think just based on some web search, I found out that Meta's Llama 2 model was rumored to be costing $20 million, and the OpenAI model definitely exceeds hundreds of millions of dollars. So it's very expensive. It's not for everyone, right? It's only those big companies or companies that have deep pockets who can afford to do that. And luckily, some of these companies decide to open source these large language models that are pre-trained, and then we can further fine tune on these large language models. But when I say open source, it doesn't mean they open source everything, right? They open source the model weights, but they don't always open source the training data set and the detailed methodologies. But just a few days ago, I heard that this institution called Allen AI Institution, they sort of open sourced everything, which is pretty cool. I think it's good for the community. Are these models free to use? It really depends, right? ChatGPT obviously is not free. And TI's Falcon model was the first open source foundation model released, last year. So when you use these models, definitely look into that. And if you want to use it to build some, commercial products. How can we use the open source models? I think there are many different ways of interacting with an open source large language model. We can do prompt engineering. I think this is what most of us do, right? When we work with ChatGPT, we're essentially just doing prompting. Fine-tuning large language model, is also pretty common approach, but it's more expensive. Right? You need to know exactly how to do fine-tuning. You need to know how to prepare the data. But why are we doing this? Well, we do fine-tuning because we want the model to sort of perform some task-specific use cases. And you want to tailor the model, the large foundation model, which was pre-trained by Meta, by TII, the Falcon models, and we would like to adopt that to our own use case, right? But the model is trained on very generic data set collected from web. That's why we need to feed domain-specific data to it, and that's the process of fine-tuning. And of course, when you look into fine-tuning, there are many different ways of fine-tuning. We'll touch on that a little bit today, okay? And then, of course, we can build applications on top of it. There are AI agents that we can build on top of large language model, and there's, the RAG, knowledge search or retriever augmented approach is also becoming very popular. So we'll briefly talk about that very shortly. So these large language models, right, are foundation models. There are different types of large foundation models out there. There's the vision models, right? There's the LLMs. And some popular ones, such as Facebook or Meta's, Llama model, Google has Palm. I think UAE's TII has, the Falcon model. Anthropic has Claude. OpenAI GPT-4. Rumely, they're working on GPT-5. Image models, Stable Diffusion, DALL-E model, and Google also recently just came out with the Gemini, right? This is the evolution tree. This space is already very crowded. If you're thinking about getting into this space, to work as a LLM engineer or machine learning engineer focusing on, natural language processing, I think there are a lot of, opportunities out there. And obviously there are a lot of things to learn, but you definitely will come across some of these models. But understanding how it, the whole evolution, I think will be helpful, especially when you look into some of those literature and do reviews. That will help you understand what to focus on. Okay, this is a quick review of the large language model life cycle. From left to the right, usually we start from a pre-trained model. Right? So before we have before we train the large language model, we have to prepare the data. That's actually a lot of work. And then we start to pre-train the data, right? So we go from a model that has random parameters, which is like an untrained model, to a model that has been pre-trained. So it goes through the pre-training process. And that pre-training process, is basically the next token prediction model, for example. And both, most of these models, such as GPT-4, Google's Bard, and they are decoder-only models, right? So we pre-train them, and it becomes an unaligned model. So after the model pre-training, the model has the world knowledge, but it doesn't always follow instruction. So you have to basically, tune the model and align the model so it's not spitting out toxic output, right? And it's following your instruction. So it can actually have a meaningful conversation. So we go from an unaligned model, right, to an aligned model, and this is usually done using reinforcement learning. But recently there's some innovation around in this space that can reduce the amount of like the dependency on a lot of label human annotation, and it's called a DPO approach. Very exciting. And along the way, when we do a model alignment, usually the LLM engineers will also do the instruction tuning, which is training or tuning your model to follow instructions. We'll briefly talk about this, and it's part of model fine tuning. The ChatGPT model we're working with, it's basically has already gone through pre-training, instruction tuning, and also alignment, right? So that's why ChatGPT is able to sort of refuse answering some questions, because it has been fine-tuned or aligned to avoid saying something that's toxic, for example, or very biased. And that's the model we are dealing with when we work with ChatGPT and Meta's Llama 2. These models are also instruction. They have the pre-trained large language model that we can use to do instruction tuning ourselves, but they also provide the instruction tuned version that we can directly use to have some sort of Q&A and conversation. But most of the company will want to tailor or customize these open source large language models, and that is the fine tuning, right? So you want to fine tune your model to be task specific. That's when you're going to feed your own company's data or your own domain knowledge data into the LLM. You go through the fine tune and basically reparameterizing your model, so the model can actually follow the instructions and be tailored to your domain knowledge, right? And of course, you can also distill the model and create a much smaller version, which is sort of like teacher and student model. And a student model is much smaller. It's not as good as the teacher model, but it's much more, it runs much faster and it's much more lightweight. That's also a very popular approach. So this is the life cycle. It starts from pre-training all the way to, for example, fine tunings and also distillation. You need to understand, which type of model you're dealing with when you build LLM applications. All right. So when do we use each, each approach? You might have questions such as, should I pre-train my own model, right? I guess most companies wouldn't want to do that because the cost is too high. And should I just use an aligned model such as ChatGPT or GPT-4 using the OpenAI API, or use the Llama model, right? Or should I fine tune an existing large language model to fit my use case, right? So these are the questions you need to ask yourself before you get started with large language modeling. In the pre-training space, one classical example is the Bloomberg GPT, right? It's a pre-trained large language model for finance, which means the data they feed into this large language model is already finance specific training data. And they did a lot of, data preparation and then just pre-train the model from scratch. That cost them millions of dollars, right? Very expensive to train. But if the company has a very specific use case and then they have the capability to do that and also the budget, then why not, right? But if you look at, pre-training, and it's not just expensive, right? It's not for everyone. It requires, millions of dollars, terabytes of data, because, you need to feed decent amount of data into large language model for pre-training in order to get good results. Compared to fine-tuning, right? And the data that's used for fine-tuning, you can begin with like 10,000 records to fine-tune your open source large language model, and the cost will be significantly lower, right? And you can use also parameter efficient algorithms that can help you sort of reduce the training cost. And on the right-hand side, ICL stands for in context learning. So that's basically just prompting, right? So it doesn't change the model weights. It doesn't require any GPU cards. And you can usually get the results in seconds. There's the zero shot, one shot, few shot learning. All you're paying for is the cost of making the inference. That's how we're paying ChatGPT or OpenAI, right? Pre-training, too expensive, not for everyone, unless you have a very specific, good, reason to do that. And comparing, pre-training to fine-tuning and prompting, pre-training is like, the middle school, high school, students, they've spent 10 years learning all the fundamentals, because we feed math, writing skills, chemistry, they go to different classes to learn all of these fundamentals, right? That's like the pre-trained models, and fine-tuning is like the college student, because when you go to college, you graduate from high school, you need to pick a major. Do you want to specialize in accounting? If you want to specialize in marketing, computer science, doubly, that's fine-tuning. And then prompting is like you get a job, right? When you're on the job, you rarely attend classes anymore, right? You just like prompting and just, learn on the job. You have an existing skill set, just like you have an existing pre-trained or fine-tuned large language model. You just want to use it. That's like prompting, okay? Okay, so after pre-training, we're going to do alignment or instruction tuning. And reinforcement learning is also a very expensive approach, but it works really well. And recently there are some other approaches. And fine-tuning is like something I think that's more practical for most of the companies or people who want to build large language model application, along with the indexing approach and RAG stuff, which is also becoming more popular. So most companies will choose to work with either a paid API. You've seen a ton of startups building applications on top of it, OpenAI, but unfortunately, I think they're not. I think the innovation is on how you're going to use the OpenAI API to drive use cases. But if but then your entire application depends on OpenAI. So if OpenAI made any changes, it's going to significantly affect the model's performance. So yeah, you don't have a lot of really big moat there, but so you have to figure out like what's the real use case here, right? And OpenAI API or whatever large language model you're going to use, that should not be the core advantage of your product, right? It's the use case and application that's driving the growth. Okay, and then of course, based on fine-tuning models, we can do further fine-tuning and distillation to get a smaller model. So how do we ask large language models to perform specific tasks, right? There are different approaches. In practice, we want our models to perform specific, tasks, right? So there are 4 different categories. The first approach is just in context learning. There's also the indexing approach, and so retriever augmented generation, RAG, is a part of that. So in context learning and RAG, they don't make any changes to the large language model. So you don't need to be an expert in deep learning or LLM, right? You're just using these models. You're either prompting the model or you're indexing the data and doing retrieval. So that's relatively easier, and it doesn't require deep knowledge about large language model. The third type is fine-tuning, but there are different ways of fine-tuning your models. And one of these approaches is more similar to like transfer learning, right? And what's more, I think, practical is the parameter efficient fine tuning called PEFT. It updates all layers in your model, and it does this in a more efficient way. So let's go through some of these examples. So in context learning, basically it's just prompt engineering, right? You can use off-the-shelf LLMs, any types of any large language model to solve tasks without the need to fine-tune it. Okay, so we're using it at the inference time, and usually it does really well. We all had the experience with ChatGPT, right? And it's a specific method of prompt engineering. You have to provide to model, some sort of demonstration of the tasks you want it to perform, right? And there are different types of prompting methodologies. There's zero shot, one shot, and few shot learning. There's chain of thought, tree of thought, different ways, and people are just getting more sophisticated, really trying to unlock the potential of large language models. There are a lot of publications around that. If you're interested, you can look into that. But I think this is a great way to get started with building your large language model driven application. Just work with an existing API, right? RAG is definitely a more sophisticated approach, and it's very popular right now because a lot of companies realize that, first of all, prompting doesn't necessarily solve your problem, because the way LLMs talk, right, depends on the training data. It's just learning everything from the training data. So sometimes training data can be outdated, right? So for example, like back in 2022, or maybe beginning of 2023, if you ask a question like who won the 2022 World Cup, it doesn't know. It will tell you, and it's instruction tuned. So it will tell you, oh, as a large language model, my knowledge only, up to end of 2022 or something like that. So it doesn't know the new knowledge, right? And also a pre-trained model or the fine-tuned models are usually have pretty big hallucination problem, right? So it starts to blabber and it doesn't spit out the truth because it was designed to give you an answer. And there are a lot of research around this. And one way to tackle this is just to build a knowledge base, right? So if you have your own domain data, you can either build knowledge base and index those data in a vector database, and then you do the search, right? Or you can just use those data to further fine-tune large language model. Let's talk about RAG. So this is what we call like a naive RAG, which is just very simple retrieval based approach. But let me help you understand how that works. So first of all, you need a knowledge retriever. You need a knowledge base, which is a vector database that indexes, the data. It's like, if you would like to search for any kind of documentation, and then you can index the wiki pages of your company, in these vector databases, and then you can use large language model to use RAG to, basically do Q&As, right? And ask questions about your company's policies, and it will help you find those and give you answers. And you need a large language model. Most companies will probably use OpenAI, OpenAI API, right, to leverage the GPT-4 model, but it's used to either do generation or do the embedding. But you don't have to stick with the OpenAI embedding method. Okay, so first we have our internal knowledge base, right? Whatever data you have to index them in the vector database, right? And indexing, there are many different ways to do that. And FICE, right, is just one of these, approach that allows us to do nearest neighbor search. So imagine you have millions of documents. How can we search and find the document that we need or similar documents we need really quickly, right? Unlike the traditional search engine, it doesn't use keyword or token-based, search, right? So for example, Elasticsearch, it can do keyword-based because it does, the indexing this way. But when we index a document, right, we sort of need to create an embedding out of it. It's like a vector. You chunk your documents into different parts, and then you index each one of those parts, right? And then put that in the vector database. So that means a brute force approach is to every time you ask a question, you have to compare that question, the vector, to millions of documents all at the same time. And that is very expensive, right? Of course, there are ways to make this more efficient, and vector database does this really, really well. Okay. So we index these documents in the higher dimensional like embedding space. These documents will have similarities, and they're closer to each other if semantically they're close, right? And that's based on similarity. Okay, so we have to create the embedding and turn these documents into vectors, and in the vector space, the similarity to decide how close they are. Okay, so that's the first step. And then we're going to ask questions, right? Who won the 2022 World Cup? So the knowledge retriever is going to embed this question into a vector, because you need to do the basically you're going to vectorize this question and then do a search in the database, vector database, and see, to retrieve the similar, documents or the answers, right? So that needs to be sent to, a large language model, or, that does some sort of, create embeddings, right? Let's say we use let's say OpenAI, and it returns the vector, right? The embeddings, and that embeddings are going to be sent to the vector database, which is the question, right? The Q here means it's the question vector. And then it projects that to the vector space and try to use algorithms such as FIES to do the nearest neighbor search and find the closest documents. Okay, and after that, it's going to basically find the closest one, and there's a ranking process there. But the similarity search algorithms will return you the top, or let's say the most similar document, and it return you that document as the document. That's the context, right? But there's also a more advanced approach where it does the re-ranking, right? But we'll leave that to another topic. So we find a hit, that's the similar document, right? And after that, we are going to send this embedding or this document, right, along with the question, okay, as the context, and we're going to send that to the large language model. And now we're asking this question and using the large language model to generate an answer. It's almost like, you already have the answer because we search and we find it, but we're going to use the large language model to sort of rewrite the answer. Okay. So that's in a nutshell how the naive-based approach, RAG model works. Okay, and this is actually very powerful. And Microsoft recently came out with a paper just comparing this to the traditional fine-tuning approach, and found out that this might be more effective in a lot of use cases. Okay, so that's RAG. We can go through several stages, right? Indexing your documents, and then it does the retrieval, and then it does augmentation and generation. Okay, we can do re-ranking. Chunking and data preparation is also very important if you would like to build RAG applications. That's RAG, a very brief introduction. Now, as I said, in context learning and RAG, they don't make any changes to the model itself, right? But there's also fine-tuning. So there are different ways to fine-tune your models. Some of these are, for example, just feature-based approach. Let's say you have, labeled training data set, right? You pre-train the transformers. Let's say, imagine this is a large language model. And then you have the output embedding, right? You directly use this embedding to perform, certain tasks, right? This is not fine-tuning, but this is how we can use a large language model. Directly use it for training the classifier. For example, we can use BERT, right, to do classification, okay? Fine-tuning, there are different ways to fine-tune the models. And of course, we can take the output layer, right, of the transformer, and then we're going to train a few more layers of neural networks, okay? And so you sort of update the dates by training a new model, right? That's one way of fine-tuning it. Or you can just update all the layers, including, okay, your original large language model all the layers. And parameter efficient models usually will retrain or sort of update all the layers of your models. Okay, but it does this in a more efficient way. All right, let's talk about parameter efficient fine tuning. But before that, I would like to just briefly mention the instruction fine tuning. Right, instruction fine tuning is a part of fine tuning family, and it trains your pre-trained large language model to follow instructions. Right? So we do this because we want the models to maybe change the behavior, right? Learn how to respond more consistently. Okay, and make your pre-trained model to become better at conversation, okay? Or sometimes you want your model to gain new knowledge, right? So you want to increase the knowledge of a new specific concepts, okay? Or correct an old incorrect information. And maybe sometimes you may want to do both. So we can do this through fine-tuning, okay? So instruction tuning happens usually after the pre-training stage and before the alignment, okay? Some of the famous, examples of fine-tuned large language model or instruction-tuned large language models are such as ChatGPT, right? The Falcon has, the Falcon 40B Instruct, Alpaca, and also Copilot. These are instruction-tuned models. Okay. Fully tuning the models, as we said, fine-tuning sometimes involves, updating all the layers of large language model, and that's called full fine-tuning, and that is very expensive. Okay, because and also the models are just getting bigger and bigger, right? Comparing GPT-4 to GPT-3, it's so much bigger, right? So the cost of fine-tuning also keeps growing, because if you want to update those layers, then you need more GPU cards to do that. Okay. I'm going to skip some of these details, but one method, which is called LoRa, and also the QLoRa, these are low rank adaptation of large language models, but it allows you to do the fine tuning more efficiently. You can look into that if you have if you have interest, but I think if you want to do fine tuning, definitely you need to consider LoRa or QLoRa. But if you look at the entire taxonomy of fine-tuning models, there are actually many different approaches, right? There's one approach called soft prompts. It's also called prompt tuning and prefix tuning. These two are also popular. Some of them are adapter-based, so adapter-based models. But the more practical ones are actually model reparameterization. So LoRa and QLoRa basically falls in this category. There are a lot of different ones, but I think these are based on the research papers published out there. And not all of these are actually popular in the industry, but LoRa is definitely one of those that are very popular in the last few years. Okay. All right. I think I'm pretty much at the end of it. Just quick introduction to large language model. And if you're interested in getting started, I would like to point you at the right direction. So to be able to become a LLM engineer or a data scientist that specializes in natural language processing and LLM, you first need to have basic machine learning and AI knowledge, right? And so, or I should say, deep learning. So you need to be familiar with PyTorch or TensorFlow, one of these libraries. PyTorch is getting more popular recently. To work with transformers, use Hugging Face, right? Definitely look into these to build the fundamental skills. You do need to have the basic NLP skills, right? Large language modeling. Using the model itself is quite straightforward, but you need to do a lot of data preparation, and a lot of time it's text data manipulation. So you need to understand how to do text pre-processing, and even data cleaning, maybe sometimes you need to do data scraping, data annotation as well. So these are the NLP related knowledge you need to have, and of course you need to understand what's behind, what's powering these large language models. So you need to understand how transformer architecture works, the sequence models, attention mechanism, some of the transformer architecture. And then when it comes to LLMs, I think knowing how to do pre-data processing is very important if you want to do pre-training or fine-tuning. And data augmentation is also very practical, skill set you need to have. And when it comes to the model itself, there are many different types of model. There's encoder-only model, encoder-decoder models, and GPT models are, most of the GPT models are decoder-only model. Okay. After you've learned these basics, and then you move on to, applications or fine-tune the large language model. So we briefly talked about in-context learning, prompt engineering, then indexing, RAG, and also parameter efficient fine-tuning. So these are the things you need to learn if you want to become an LLM engineer. In terms of the resources out there, WeCloudData has an AI engineer, boot camp, but we also have a LLM NLP course. It focuses on fine-tuning of large language model as well as building RAG applications. We introduce traditional NLP methods as well as data pre-processing. This is just the LLM course in our AI engineering bootcamp. The bootcamp also covers deep learning fundamentals. It covers computer vision as well as machine learning operations, how to deploy large language models, and traditional machine learning models in production. So this is a pretty complete and comprehensive bootcamp. If you're interested in taking your data science career to the next level, this is definitely the best bootcamps out there. But there are also a lot of great online resources. Deeplearning.ai has a lot of resources and free short courses. It doesn't go very deep, but it's a really great primers for anyone who want to learn more about large language model. Stanford also has the CS 324 and 224 course. Definitely look into those. It has a lot of theory. Yeah, that's about it. And in terms of the machine learning engineering MLOps bootcamp, it's 6 months part-time, and the student will be working on portfolio project, and they go through AI fundamental course, computer vision, LLM, as well as ML ops and LLM ops. So it's a pretty complete curriculum. And student also has the option to join real client project, to practice their skills and build experience that they can add on their resume. And we also include 6 months of one-on-one career mentoring to help you get a job. So that's what we offer at WeCloudData. All right, I think that's it. That's all I want to present today. I hope you find this session useful. I still have 10 minutes, so if you have any questions, feel free to ask. So there's some questions. One, can you share the recording after the session? Yes, the sessions are always going to be available on YouTube. So you can go to YouTube, youtube.com/WeCloudData. Yeah, so the videos will be uploaded to our YouTube channel. So you can find them in, I think, the meetup events, webinar events recording. Yeah, so it should be here. You can find these, okay? Another question about which LLM was fully open sourced. I think it's Allen AI's, large language model. So look into that. And the Falcon models and meta models, they open source out of weights, but not necessarily all the details. What are the career opportunities for the graduate in language model or MLOps? Yeah, so there are a lot of opportunities. I think even, so data scientist, I think after you finish this program, you're basically a data scientist specializing in NLP and large language model, or you can choose to specialize in ML engineering as well, because in this program we cover computer vision, ML ops as well. A lot of companies will basically want to retrain their data scientists to be able to do large language modeling and building RAG applications. These happen to be the topics that we cover, but it assumes that you already have some data science experience and at least you understand the basics of machine learning before you can get accepted into the program. If you don't know machine learning, we have some material that you can use to self-learn. And then, after that, we can accept you into the program. What career should you look for if you already, your thesis is regarding this? Maybe the job title is not very popular yet, but I start to see like LLM engineer, but that's too narrow, right? I don't think there are a ton of jobs out there, but there are actually a great deal of opportunities out there that's related to large language model because, think about this way. The banks have been doing data science and machine learning for so many years. And now large language model came out. Every bank, trust me, they are doing internal proof of concepts, right? We've worked with insurance companies and banks, and we've done training for them as well. There's huge interest in this area. So they're asking their internal data scientists, machine learning engineers, basically to do experimentation, proof of concepts. Most companies are still at this stage. They need talents, right? Who's more specialized in this field because the companies all want to build this to drive their internal efficiency. I know, one of the director of data science in the largest bank here, and they are basically building large language model driven agents to write SQL queries. Their job is not what they're trying to do is not to replace data scientists or data analysts. They know it's not possible, but they're trying to build an internal tool that can help people to write queries more efficiently. Because imagine you're a new data analyst, right? You're not that familiar with the entire data warehouse. But if you talk to a large language model, which is fine-tuned for that purpose, it can actually give you a lot of useful information. But of course, it's going to have hallucination. But that's the research people are working on, and they built a lot of use cases like that. There are a lot of applications with chatbot related, right? But the bot itself is driven by large language model, so you have to fine tune that. In one of the real client project, we work on with a media company, our students are actually helping the company to deploy a chatbot that specializes in finance, right? The chatbot is already in production, and we work with their tech lead directly to deploy that model in Amazon Web Services. So that's very exciting for the students to build their experience, and they can get jobs really quickly. So that's so anything related to large language model fine-tuning, RAG, you're sure be able to stand out if you have those experience on your resume, whether it's research or based or some practical experience, because there are not a lot of people out there who have this kind of experience yet, right? Software engineer having knowledge of Gen AI is awesome. So so you can. So today we talked about fine-tuning all of the stuff, right? But if you're a software engineer, and I think that's your specialty, and your focus should be on how to leverage large language model to build application, and RAG might be something you should focus on, right? Because I see a lot of projects, they work really well as a proof of concept, but when you turn that into MVP and deploy that in production, there's a lot of engineering effort going on. And most of the data scientists are not coming from software engineering background. So they can build experiments, they can build some prototype, but they will need software engineer who understand Gen AI to put that into production, either machine learning engineers or software engineers, right? So I think you need to be familiar with this kind of concepts. Also, get some experience, building RAG-based application. That will definitely help you. Oh yeah, that's awesome. You're already building a chat application for a company. That's cool. What are the fees for the bootcamp, and can we apply for OSAP? The fee is I'm not on the operations side. I believe it's 9,000 or 10,000 Canadian, and around 7,000 or 8,000 US dollar. We do have financing options. There will be line of credit as well. So yeah, definitely visit our website, leave your information, or talk to our operations team, and they will tell you all the details. You can go to WeCloudData.com to find more details. you should be able to find the courses under courses, AI engineering. Yeah, so this is the AI bootcamp. It should give you all the details. There's also, I think there's, the boot camps, but you can click on short courses, and under AI engineering, there are 3 courses. You can do the large language model. If you're not interested in the entire boot camp, you can just do the short course, LLM course as well. So yeah, check them out, and you can fill out your information here, and our operations team will reach out to you if you're interested. No problem. Any other questions? Where can we find the materials for self-prep for ML before the MLOps bootcamp? Yeah, so it's available on our learning portal. You have to talk to our operations team, sign up for the course, and then we'll give you the self-paced learning material to get prepared. Cool. If there are no further questions, I hope you find this session useful. And yeah, we have some other generative AI related events in the near future. So feel free to stay in touch with us, and we look forward to seeing you guys in the near future. Thanks for joining this session. I appreciate it. Have a good evening.